Hello everyone, this is Mukundan Raghavan, and in this video we are going to explore the Pinecone. In previous videos we have seen what is vector database, why do we need vector database, and what the basic vector looks like. And this video we are going to start our hands-on by getting into one of the famous vector database, which is Pinecone. Still, we have a lot of other vector databases available in the market, but we need to pick up any one to start our hands-on. As part of that, we are going to pick up the Pinecone for our hands-on. And today agenda would be getting into the Pinecone and creating our first account. Then we are going to explore the Pinecone interface and console for doing the basic activities. And we are going to create a first vector index. As we all know that vector can be saved into the vector database using the index. There are main three reasons. One is in order to have the faster query performance and in order to have the similarity search very effectively and also to have the scalability. Even in traditional databases, we have the index, even though we have the exact match. So that means that obviously when you go for the vector database, you are going to do the similarity search among millions of data, even that too unstructured data. So it is very must that every vector database will have the index. Before creating or before saving the vector, we need to create the index for that. And we are going to create and configure the vector index for the given Pinecone account. Then at the very basic level, we will be adding one vector to the Pinecone using the console so that you don't need any programming language at this point of time. And we will see how it works. First and foremost point, let's go to the Google and go to the pinecone.io, and you can sign up by using the Google account or you can create your own account. Make it very simple. I'm going with my Google account, and this is how the front page looks like from the Pinecone. And you have the multiple things. Get started or the developer quick start. It will be having the code snippets, how to connect to the vector database, how to create the index, how to insert or upsert, how to do the similarity search. Everything will be there under the developer quick start. And even we can use the multiple languages, Python, Node, Go, Java. Basically, we will be seeing this in the coming videos. However, it will have the basic thing, how to initialize the client, upsert data, query data, very simple steps. Then database, in the database, as we discussed, we need to create the index by using either code or console, and backups as per the standard procedure. They will be having the backups and some assistant. Okay, create an assistant, inference. Basically, when you want to create the vectors, you need to have the embedding model that we have discussed. So here you can use some of the embedding models, text embedding models, and API keys. Even though you create the Pinecone vector database here or vector index here, you need to connect through the programming language or APIs. So in order to do that, you will be having the API keys and managing your members from the Pinecone vector database. So here I am the default one because I have created this account. Apart from that, your small statistics here, write units, read units, storage, and so on. Since it's a free account, you might be having very limited storage. However, that would be great enough to complete our hands-ons. Apart from that, we have the docs, documentations, settings, and our profiles, building status, everything. It looks like almost same like any other website for giving the account, for giving the basic things and exploring the knowledge base and having enough documentations. Now let's go into the next step. So now we have created our Pinecone account seamlessly by using our Google account, and we have just explored the Pinecone interface in a simple way. And now we are going to create our vector and insert our vector. So for that, let's go to the database, and first one we are going to create index. Let me create index as demo. And since it's only the demo index, I am not going to give thousands of dimensions, because when you insert some vector, it should have the data for all the dimension. For example, if I mention 1000 as my dimension, I need to have the 1000 input inside the vector. Let me give 8 dimension, since it's a very simple vector insert. And this is a metric will be used to have the similarity search or considering the distance between one vector to another vector. So as of now, we will consider this metric as a default one. But in coming videos, we will try to understand what are the other available metrics, such as cosine, Euclidean, dot product. But as of now, we will go with the default. And here we will go with again serverless default way, and it is going to create on AWS. Okay, region default, deletion production, which means that when you enable, even though you try to delete it, it will not be deleted. So that's all, and I'm going to do with my starter plan. Yes, that's fine. It's only demo. Now here you can see demo being initialized, and it has the metric will be used as a cosine, 8 dimension, and the host name. Cloud that we are using is AWS, region from US East 1, and type is serverless. Now we have everything ready and record count is 0. Click on add record. Now namespace is one of the hierarchy or one of the logical grouping where you will have more segregation on what or where you are saving your vector. And on vector itself, you can give some metadata. Basically, you can give some information about your metadata. So here I'm giving ID as A for my vector. And let me give some vector which is having 8 entities or 8 information because we have mentioned dimension as 8. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. I don't need the square brackets because it is for the coding perspective. And note down one more point. There is something called add sparse data. So we need to see the metric cosine and we need to see the sparse data in coming video. But this video, we will try to insert or upset. Just click on upset. So upset is successful. You can see the message. Just refresh. It will take some time. Let's wait for that. So now we have created the simple namespace by default. Number of vectors in that would be only 1. Let's go to that. And here you can see there is only one vector and it will be having the ID as A that we have given as a metadata and values are all ones having 8 information or 8 dimension. And that's simple. So we have just created our Pinecone account. We created our first index called demo and it has some information including the metric and we inserted our first data and we are able to see that. And even we have given some metadata about our vector such as ID and we are able to see in the same console itself, you can browse the records. If you have multiple vectors, you can query it and we can have the metrics overall how your vector database works. Example, read units and write units, request latency, request per second, storage size, record count, everything. And even we can also see the namespace. So what are the namespace we have? By default, we have the default namespace. And in browser, you can have the multiple option, list the items. Here you can see it will be showing 100 items at maximum. And here you can add again vector by using the same way. Even though it looks like very simple to add the record and query the record, since we will have millions of record in the vector database having thousands of dimensions, it may not be the very effective way to insert the vectors. So we will be having the programmatic approach and we will be seeing how to do that by using the developer quick start in coming videos. So with that, I will be just concluding this video. However, I want to add one more bonus point. Recently, I have came across same like ChatGPT. There is another website called u.com, almost similar to the ChatGPT and having the same kind of setups. If you want to explore, you can explore further. And this is all about this video. And always be a rainbow in others' cloud.